Yellowstone National Park's Beehive Geyser is renowned for its towering eruptions, but also for its irregular timing. However, as the Yellowstone Safari Company explained on Tuesday via social media, there are small indicators that signal an impending eruption. Accompanying footage shows these indicators activating before the main eruption. The company explained, "If you see those small plumes start spewing water, that means in the next 20 minutes, you'll be treated to a geyser eruption longer and higher than Old Faithful." According to the park, Beehive Geyser is a favorite performer in the Upper Geyser Basin, but erupts only once or twice a day at unspecified times. Steamboat Geyser, located in the Norris Geyser Basin, experienced 128 major eruptions between March 2018 and the end of 2025. This may not seem particularly impressive at first. Old Faithful Geyser can erupt that many times in less than 9 days, but for Steamboat, a true giant geyser, it's a remarkable feat. Steamboat eruptions can shoot plumes as high as 116 meters, 380 feet into the air. Eruption intervals or periods between eruptions can be as short as 3 days or as long as 50 years. During the period 1985-2017, Steamboat erupted only 15 times. According to historical records, Steamboat has alternated between dormant phases, few major eruptions, and active phases, many eruptions at intervals of days to weeks, as it is currently experiencing. The two previous active phases occurred in the 1,960 seconds and 1,980 seconds. The current active phase is unique because it is so well monitored. Emission signals were recorded on temperature loggers on the spillway, nearby seismometers, and USGS flow gauges. There was even baseline data on the timing of Steamboat's eruptions and visual observations collected by geyser enthusiasts. This remarkable data set and its eruptions motivated a team of geoscientists to study the geyser and why it might be experiencing renewed activity. Their research was recently published in the Proceedings of the National Academy of Sciences. The team found that the extreme height of Steamboat's eruptions was likely due to the depth of its bubble traps, shallow cavities or structures that directly supply air to the eruption. Geysers with deep bubble traps have higher eruptions because more air is stored within them, generating more energy to drive the eruption. Eruption volumes were estimated to range from 134, 538 cubic meters, 4,730, 19,000 cubic feet for 29 eruptions, which occurred under the low wind and rain-free conditions necessary for accurate estimation. For comparison, 250 cubic meters, 8,830 cubic feet, is about 1/10 the volume of an Olympic-sized swimming pool. Old Faithful's eruption volume is typically no larger than a relatively small 30 cubic meters, 1,060 cubic feet. Surprisingly, the volume of erupting air doesn't stop at intervals before or after eruptions, as is the case with some other geysers, such as Old Faithful. Several Earth processes are known to influence geyser eruption intervals, including earthquakes, weather conditions, and air availability. At Steamboat, there's a slight seasonal effect, with longer intervals in winter and shorter intervals in summer, most likely due to changes in subsurface pressure related to groundwater recharge. Now the big question: why did Steamboat begin its active phase in 2018? Precipitation, rain divided by snow, is most likely not the cause. Streamflow can be used as a rough proxy for regional rainfall, and very active years at Steamboat did not accumulate with very low or high average annual discharge in the Yellowstone River during 2019. Earthquakes are also unlikely to have contributed to Steamboat's reactivation. Seismic eruptions occurred west of the Upper Geyser Basin in the summer of 2017 and February 2018, but neither earthquake shook the ground hard enough to affect the geyser.